Hey, it's Nick. Welcome to Module 2, Chapters 5 and 6. We're talking about Active Directory. Now imagine, if you will, you ordered a new computer recently and it just came in the mail. You unbox it, you plug it in, you set it up. And part of that setup process is creating a username and password that you're going to have to type in every time you want to use the computer. Now, fast forward maybe a year or so, your computer bails on you, gets stolen, whatever, and you have to buy a new one. Now, when you buy a new one and it comes in, you set it up, the user account that was on your old computer won't be there. You've got to make a new one. So the reason it's that way is because we're using something called local authentication. What I mean by the word authentication is proving you are who you say you are. In this case, by the use of a password. Now, once again, we're talking about local authentication. And the way local authentication works is on any Windows computer, we have a small database. It's called a SAM database. And that SAM stands for a Security Account Manager. That's a small database on your computer or on any Windows server for that matter that stores user accounts, passwords, groups, things of that nature. In our case here, Miss Jane, on her Windows computer, she has a username of Jane, and she's got a password of I Heart Puppies. Now, they have a server in this office. The server also has a local SAM database. And this SAM database will contain Jane's user account that we assigned to her, that we assigned on this server, and we were nice enough to make it the same thing as she's already used to on her computer. Now, we also may have created several other user accounts for other users that may be accessing resources on our server. Now, what if Jane changes her password on her local computer? Well, that password only changed in that local SAM database that lives on that computer. That server knows nothing about that. Okay? So Jane has to keep it in her head that to log into her PC in the morning, she needs to use that Pineapple's password. But if she wants to access server resources, shared files, and what have you, she has to use the I Heart Puppies password to authenticate across the network. Now, this is the way we do things in small work groups. We end up having this local authentication and with every machine in the network. And the challenge that presents is when we want to secure our network a little bit better. That makes it a challenge because if we have several hundred computers to manage, we end up having to go set up our security settings on all these computers one by sitting at the console, logging in, touching them, and changing our settings right there on the computers. And that's a lot of work, okay? Especially if you have thousands of computers. And no one likes to do that. It's really inefficient. So in walks the directory services model. Now, the directory services model is going to use a directory services server. And on this server, we have a database called a directory services database. And this guy will keep up with the user accounts and passwords for everyone in the network who is a part of this directory services network. Now, when these people want to log in to their computers in the morning, they type in their user account and their password like they normally would, but that user and password combination does not go and bounce against their local SAM databases. Instead, it comes across the network and hits on this directory services database. Assuming their password information is correct, the server will respond with "you're good to go," and they log in and do what they got to do. Now, this adds some flexibility to what we're doing here. we are now able to manage our security settings better by utilizing our directory services database. Now we can make security changes to all the PCs who are a part of this directory services network without having to go to each one and sit down and log in. We can do it across network using directory services applications. Now we don't just have to manage user accounts and passwords. Here we can also have other server objects we're managing, printer objects, things of that nature that we can control in our services, our directory services database network as well. Now, when it comes to how Microsoft fits into this, Microsoft has an application called Active Directory. This is Microsoft's directory services application. It's what they use to do what we had just discussed. And there are several pieces to the Microsoft Active Directory puzzle. Its job is to centralize authentication and security. And those pieces of the puzzle I mentioned: user accounts, computer objects, server objects, groups, OUs, built-in containers. And we'll talk about those in more detail a little later on. Let's first talk about how Active Directory is put together. And I want to talk about that. I want to introduce that this way. When I was going to college the first time, I went to UCA, and I stayed in an apartment complex called Salem Park Apartments. Nice little complex for what it was. And Salem Park Apartments had a certain set of rules that we had to abide by if we wanted to keep staying there. Now, Salem Park itself was owned by a management company. That management company was called Lindsay Management. And several of the rules that Salem Park imposed upon us residents actually came from Lindsay Management, their parent company, or their management company. However, because of the location we were in, Salem Park had to have certain other rules that were specific to just the location or just the kind of tenants that they were used to having. In addition to what Lindsay Management, their set of standards were, Salem Park had to have some other rules in place as well for specific purposes. Now, I say all that to say this. In Active Directory, we have the security boundary, and we call that a forest, and I can relate that to Lindsay Management, or the management company that owned all the apartment complexes. Now, in our forest, this is where most of the rules for all of our apartment complexes, if you want to think of it that way, are defined. And I'm going to go on a limb here. I don't know this for sure, but I'm just going to say, for the sake of argument, that the first apartment complex that Lindsay Management ever created just might have been called Lindsay Apartments. Okay? And the reason I say that is because the first domain that we create in Active Directory in our forest is going to take the name of the forest. Okay? So we have a forest called acme.com. We're going to create a domain, or an apartment complex, if you will, a gated community. And that first domain is going to automatically be called acme.com. It will take the name of the forest. And we've got a special designation we give that domain. We call it the forest root domain. He's the first guy we made in the forest. Okay? Now, we don't have to stop there. As an apartment management company, I don't have to just have my first apartment complex. I can create a second apartment complex and call it whatever I want. Maybe I'll call it Salem Park Apartments. That Salem Park has nothing to do with the name Lindsay Management. Just like our second domain has nothing to do with acme.com. It's called winduptoys.com. However, these domains still have to play under the rules that are defined in our umbrella of acme.com. Now, they may have their own additional rules for specific purposes of their gated communities, if you want to think of it that way, but they still are playing under our umbrella. And you're going to notice some icons in both of these domains here. Each one of these domains can contain their own user accounts, their own server objects, their own printer objects, their own this, their own that, their own groups, their own users, whatever. They are completely separate entities in and of themselves, but they play in the same acme.com umbrella. They have to abide by the master set of rules that acme.com Forest sets out, or the set of standards that we require. Now, we can keep on going here and create other domains even under the ones we've already have. For instance, I've created a child domain under acme.com, and I call this child domain South, and the rest of its name comes from its parent, or acme.com. It takes the namespace of its parent, south.acme.com, and I can just keep on going from there and create an additional child domain called Memphis. It will take its parent's namespace. In this case, that is south.acme.com, making South now a child and a parent. Okay. Now, this group of domains we have on the left-hand side has a special designation. We call it a domain tree. A domain tree is simply a collection of one or more domains. So given that, what about Wind Up Toys? Would that be a domain tree? If you said yes, you are correct. A domain tree, once again, is a collection of one or more domains. So there's a lot more to Active Directory than just what I'm showing here. This is kind of what we call in the field a high level view, or a view from up high, kind of looking at it from the top here. There's a lot more detail involved, but right now we're going to leave it at this, scratching the surface of the Active Directory infrastructure. Or we're going to move on and talk about the Active Directory servers themselves. Now, whenever you install Active Directory onto a server, you install the Active Directory domain services role, that server becomes a domain controller. He is now in charge of a domain. All right, he can have user accounts, passwords, he can have groups, OUs, he can have all the pieces of the Active Directory puzzle. Now, his job, one of his jobs, is to store and manage the Active Directory database, and that database is called ntds.dit. ntds.dit. That's his job, is to manage that database. And there are several other things that we're responsible as an Active Directory server for managing user accounts, managing authentication, so people who are allowed in and not allowed in, managing access to resources. So with Active Directory, a directory services model network, we can use the user accounts in Active Directory to control access to things like files and folders, things like printers, or even logging into certain machines. We can control the security to that level with Active Directory. And domain controllers also have a job of managing replication. So Active Directory is a multi-master database, and what I mean by that is we can have several servers participating in an Active Directory database, and each one of those servers has its own copy of the Active Directory database, and they keep those copies in sync by replicating the information from one to the others using that replication process. And that's more Server 2 stuff that we'll get into a little bit later on next semester if you take it. Now, I'm going to switch gears here and talk about DNS, because you really can't talk about Active Directory without talking about DNS, because these two folks are really good friends. Matter of fact, they're such good friends that Active Directory cannot operate without DNS. Now, DNS is a bit of a renegade. He can function, exist completely on his own, but Active Directory needs DNS. Now, what does DNS do? And I will explain that this way. When I want to call someone, I'll open up my phone and I go to my contact list and I scroll through all my contacts. And in my contact list, what I have is a list of names. I don't have a list of phone numbers. I don't like remembering numbers. My brain is not capable of memorizing large groups of numbers. I'm not built that way. Okay, I can remember people's names. I'm not too bad at that. Most of us are pretty good at remembering, to some level, names. And most of us don't like to memorize numbers. If I had a phone book full of just phone numbers and nothing else, I wouldn't really know who I'm calling. It'd be kind of a crapshoot. Okay, I'm going to scroll and just press one of these phone numbers and see who I get, right? Well, luckily, my contact list consists of names, and whenever I press someone's name, my contact list has their phone number stored as corresponds to their name. And that's beautiful, because we as people do not like to memorize numbers. Well, when you get online and you go to a website, you don't punch in an IP address. Computers like to see IP addresses, just like phones like to see phone numbers. Computers like to see IP addresses on a network. But we don't like to give them IP addresses. We prefer to use a name. Google.com, Microsoft.com, things like that. So what DNS does is it gives us a way to type in a name. And DNS, when we type in that name, it will take that name, translate it into the IP address that the computer really wants. Okay? And it does this process through the clever use of resource records. Now, there are several resource records in DNS. I'm going to talk about 4 of them. Starting with A. The A record, also referred to in IP version 6 as 4As or AAAA. Its job is to do the process we just described. Translate a name into an IP address. Now, the MX record, his job is to find email servers. So when you go to email somebody and you press that send button, what's actually happening is your email goes to a mail server. That mail server then contacts the receiving mail server via an MX record in DNS. Calls up DNS and says, I'm looking for the yahoo.com mail server. And DNS says, I've got an MX record for that guy right here. Go over here, talk to him using the mail protocols. That's kind of how that process happens. More of a, once again, a high level view of the MX lookup process. The next record is a PTR record, or a pointer record, and this is essentially the reverse of an A record. So a PTR record, we sometimes call it a reverse DNS lookup. Its job is to translate IP addresses back into a name. That's useful in some scenarios, but we'll get into much later. And finally, one of the other really important pieces of DNS, SRV records, or a service locator. And I'll explain service locators this way. My wife and I like to go to the mall. She more than I, actually. When we go to the mall, the first place she usually goes to is the shoe store. Now, in our local malls around Little Rock and Conway and that kind of thing, she knows exactly where the shoe stores are. She needs no directions at all. She can just take you right to it. However, when we go to a vacation, a city we haven't been to before, and we find the mall, when we walk in there, neither one of us has any clue where shoe stores, or in my case, electronic stores or whatever, where those things are. So we have to go find the map. The big billboard looking thing that's usually somewhere toward the center of the mall. When we go to the center of the mall and it's not there, and it ends up being on the other side of the mall where you have to walk 2 miles to get there. And once we find it, it's usually arranged pretty well. You have a listing of places and types of places on one side, and the floor plan of the mall and all its levels on the other side. It's usually color coded in some way, where you can look up what you want to go look at and find it on the floor plan and be able to go there. What happened, well, what that map just did for us was helped us locate the services that we wanted to use. Now, an SRV record in DNS does exactly that. It helps locate services. For instance, Active Directory. When you log into a directory services network, specifically an Active Directory network, type in your username and password, and you press the enter key, what really happens there is your computer is sending a service request to DNS. I am looking for an authentication service, Active Directory specifically. DNS receives that and says, okay, who do I have providing Active Directory services? Do I have any SRV records for this particular service? And DNS finds it. Okay, there's the name of my Active Directory server. DC1, Domain Controller 1. And DNS says, okay, DC1 is my Active Directory server. Let me check the A record for DC1. What's that IP address? And once it finds all that information, it sends the information back to the client and says, this is the guy you should talk to for Active Directory services. The user request is bounced off the Active Directory service and you're logged in. All that happens pretty quickly. Now, we didn't always have this beautiful DNS system, domain name system, to work with. We didn't always have this automated way to translate names into IP addresses. In the olden days of computers, we had to manually punch in names and their associated IP addresses into what's called a hosts file. Now, host files live on every single Windows computer. And once you find the host file and you go in there and you say a new computer has been installed, computer B has been installed, and you want to be able to access it by its name, You don't have a DNS server to automate the process for you, so you have to use the host file for name translation. What has to happen is you go find that host file that lives at C Windows System 32 drivers etc, and finally there's a file in there called hosts. You open it with Notepad, you punch in the IP address and the corresponding name, save it, and now the computer knows how to translate computer B into its associated IP address. Now, if you have other computers in the network, you have to do the very same thing on all those computers if you want them to also know about computer B and what its IP address should be. So you can see how this kind of got old really quick. This having to punch in names and IP addresses into a manual process and to the host file. It's a lot of work. So hence the DNS, the domain name system, automating the process of translating names to IP. Now the host file still lives on every Windows computer, and it's still used, matter of fact. And in cases where DNS is not available, or there's some other purpose that you want a name to be looked up in a different way, be careful with this. You can edit your own host file, but know this: a Windows computer will look at the host file first before trying a DNS lookup. So what I mean by that is when you type in google.com, what your computer is going to do is first look at its host file. Do I have an entry in my host file for google.com? Okay, there's not an entry there. Let's move on to DNS. Does DNS have an answer for me? So it contacts a DNS server. DNS says, I've got an answer for you. We'll handle it from here. And the communication is made. Malware programs sometimes will edit your host file to put bogus entries so that you will think there's something wrong with DNS. It will put all kinds of bad entries for google.com, microsoft.com, and things like that. So you're trying to get to these websites and it's leading you to who knows where. And you're thinking, well, what's going on? DNS is not working right. It's sending me all kinds of crazy places. When really someone got a hold of your host file and put a bunch of bogus entries into it. So just keep that in mind when you're troubleshooting a name lookup. Sometimes it can be the host file. And I want to step back just a moment and mention DNS one more time, specifically DNS's role with Active Directory. 9 times out of 10, when I hear about an Active Directory problem, it really is not an Active Directory problem. Chances are it's a DNS problem. There's some kind of communication error happening from the client to the Active Directory server. As far as the DNS goes, 9 times out of 10, it's DNS, not Active Directory. So keep that in mind when you're troubleshooting as well. So our next video will be a quick demo on how to install Active Directory and consequently how to install the DNS role with it, because they have to kind of exist together in the same network. They don't have to be on the same server, just in the same network. So we'll do a quick demo on how to install Active Directory with DNS. I hope you'll join me, and I'll see you then.